Okay, so this is the second review, which is over what we've been learning recently. So once again, I'm going to show a couple, and then you guys will have to do them on your own, but it won't be too bad. So this first one, so what you need to do is it's asking you to determine if the following are similar and describe how you know. So there's three different things that we know. We know that if you have two sets of angles, okay, two sets of angles that are congruent, then those two triangles are similar. For example, if you look right here, 65 is congruent to 65. 37 is congruent to 37. All right? Because these are both congruent to each other, we know that these two triangles should be similar. So we'd write similar by angle, angle. Okay? We know it's similar by angle, angle. This one over here has the same idea. This should be a 21 right here, by the way, guys. First, we need to figure out this spot. We know the whole thing is 21. We know this part's 7, so you know this part's 14. So what you can do is you can actually create the ratios to see if because we have no angles here. The only angle we have is the one they share. Technically, they share this one. So we know they have that in common, so we know it's congruent to itself. So we know this smaller triangle and this bigger triangle both have this in common. So that's what we want. That's what we need now is the sides. We need to see if they're similar to each other. So if we take 7, we put it over 14, and we set it equal to 10 over 20, we get to see, are both these ratios the same? If they are, then that means the sides are similar to each other. Then we can say that these two triangles are similar by side, angle, side. So this would be 0.5. This would be 0.5. Well, 0.5 does equal 0.5, so we know for a fact that these are equal, that the sides are in proportion to each other. So we know that this is similar by side, angle, side. This last one. All right, so we need to break down this 25. So we know this is 20. That means that this part has to be 5 because the whole thing should add up to 25. Okay? So what we're going to do next is we have 3 sides. You have this side and this side to this side, this side to this side. So what we can do is actually set up our ratios to see if they are the same. Now, you'll notice something about the whole things, is that this is 65, so that means we need to know the whole thing for this. So what I'm going to do is I'm going to put the whole thing is 15. Why? Because they have to be the same type of ratios. If this was broken up like these are, then it would be okay, but they're not. So we're going to do it like this. So it'd be 15, or 3 over 15. This one's going to be 5 over 25. This one's going to be 13 over 65. So, we're going to compare the bigger sides to the smaller sides. If you break this down, 3 divided by 15 is 0.2. This is 0.2. This is 0.2. Okay? Because they all have the they all have the same ratio, that means that all 3 sides are similar to one another. Okay, so this side is similar to this whole thing. This side is similar to this whole thing. This side is similar to this whole thing. Therefore, we know this is similar by side, side, side. Okay, so that's a way of seeing all 3 different types of similarity theorems. Now this next one is a little bit tricky because you have to notice something. Yes, they have an angle in between that's congruent, but the angle to the left is 7, the angle to the left of that angle is 10, so this should be 7 over 10. This should be 5 over 14. This should give you 0.7. This will give you 0.35. They are not congruent in the least bit. This was tricky because if you set up the ratios, like you saw 5 and 10, 7 and 14, if you set those up, you get half. But you had to notice where the sides line up at. Because they don't line up, that means that this does not have enough information to be solved. Alright, this next part. This is going to help you with all of these. Alright, it's the same idea, just in a different form. What you always need is you need a comparative ratio. So you need a side that's from the larger side and a side from the smaller side that are both numbers. This will create our comparative ratio. So in this one it's 18 and 6. So if I take 18 and put it over 6, there's our comparative ratio. Now I can find the rest of these using the comparative ratio. So let's start with x. X is on the same level as 18 over 4, which should be on the same level as 6. Now we can use this comparative ratio in order to find our x. So you cross multiply, 6 times x is 6x. 6 times 18 should be 100. Hold on. 6 times 18 is 108.
You told me to spit my top this whole night?
Shh, go. I'm doing a video right now. I'll talk to you later. Sorry.
Wait.
I'm doing a video. Please go.
You're what?
Doing a video. I'm sorry. I will be with you guys 1 second. So x gives you 18. So the next one is 24. And so we're going to do 18 over 6 equals 24 over y. 6 times 24, 144 equals 18y. So y gives you 8. And that's how you do the rest of these, is you just find your comparative ratio. For example, in this one, it would be 20 over 16, because they're in the same spot. This one, it would be 20 over 15. And this one, it would be 18 over 9. So those are your comparative ratios. Next thing. Now, we're trying to figure out this thing right now. So what we need to figure out, okay, so actually, I'm sorry. So what we're going to do here is, you know that these two lines are parallel to each other. Because you know they're parallel to each other, you know that the smaller triangle is similar to the larger triangle. So we can set up a ratio to try to figure out what this x is. So the easiest way to do it right here is that we could take this 30, and we know that this is 5, so we can figure out this is 25. All right? So now we can set up a ratio however you want. But the thing is, when you're setting up the ratio, it needs to be comparative somehow. So that means if we take the small side and we put it over the other small side, we need to put the 25 on the same level as the 5 and the 10 on the same level as the x. Or what we can also do is, if you took 5 over the 25, you could set that equal to x over 10. Notice how the 5 is always connected to the x somehow, and that the 25 is always connected to the 5 somehow. This will come out to the same ratio if you multiply, but these are two different ways to set the ratio. So 25 times x gives you 25x. 5 times 10 gives you 50. So x gives you 2 in this case. Alright? Now this next one. So I put that question mark there because you could figure out this one first, alright, by doing simple ratios. Or what you can do is you can notice this is a whole side, so we can make a whole side over here. Now we have something we can compare. 20 and 8, we can compare that to 3x minus 4 over 10. That can be the same type of ratio. So 20 over 8 equals 3x minus 4 over 10. From here, we can cross multiply. 20 times 10 is 200. The next start is what we have is 8, and we have to multiply this. 8 times 3 gives us 24. Now, we can't just multiply this front part. We have to multiply this 8 times 3 and 8 times 4. It's like the distributive method we did back in Algebra 1. So 8 times 4 gives us 32. Alright? But now we have to get rid of this 32 somehow. So we have to add 32. So that's 232 equals 24x. Alright? Finally, we need to solve. So 232 divided by 24. That will give us x equals 9.6 repeating. Okay? So that's how you do these. So figure out the comparative things. Like this one, you compare 15 to 3 and 25 to x plus 9. And you can do the same thing here with 42 and 14 and 5x plus 3 and 21. Now the next one says, what are the three trig ratios? So your three trig ratios are sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. So that's what we're doing. Now, we're going to use that to figure out these problems. I'm going to do one of these problems, and you're going to do the rest. But I will tell you what they are, what the answers are, but you still have to figure it out. Okay? Actually, yeah. So find cosine if tangent equals 153 over 104. So we know tangent is always opposite over adjacent, right? Opposite over adjacent. So what we know is the opposite side, meaning the opposite side of the angle, is going to be 153. We know the adjacent side, the side next to, that's not the hypotenuse, is 104. So what we have to do here is you have to find the third side using the Pythagorean theorem. So if I use the Pythagorean theorem, this would be A, this would be B, this would be C. I would do 104 squared plus 153 squared equals C squared. And then if you do the whole math, 34225, you get 185. So what this is our hypotenuse. Now, why this is important to have is because cosine is adjacent over hypotenuse. We needed that hypotenuse before we could solve. So cosine would end up equaling 104 over 185. Okay? The next thing is going to be 115. This would be opposite this time. Sine is opposite of our hypotenuse. This would be opposite. 115, and this would be 277. You'd end up with this being 252 if you figured everything out. And you would get that tangent, since it's opposite over adjacent, would be 115 over 252. Okay? Same idea here. Cosine is adjacent, which is 231 over 281. You'd solve using the Pythagorean theorem, and then you'd find whatever opposite over hypotenuse was right there. All right.